This video is the first one for section 2.1 of Pre-Calc 11, and the first one for sort of the first half of the trig unit of this course. So trigonometry in Pre-Calc 11 kind of falls into two broad categories. 2.1 and 2.2 kind of go together, and then 2.3 and 2.4 are very different. So this is the start of the first bit of that first chunk. So we're going to be looking about something called standard position. But before we get there, we got a few things we got to set up first. So something that you may or may not know is that when we're working with angles, we can draw them in a place that we wouldn't normally expect. So we're used to thinking of angles in terms of triangles. But another place that we can deal with them is on the thing that we know as the Cartesian plane, which is a name that you may or may not remember. But the Cartesian plane is just this thing, your axes, your x and your y. When we do that, there's a specific way that we're going to draw them. So if you have an angle that looks something like this, right, just a gap between two lines, each angle has, well, like I said, two lines, and those lines have names. So as a group, they're called arms. And the place where those arms meet, right, so this is an arm, and this is an arm. The place where those arms meet, this point over here on the left, is a word that you know used in a different context. It's called the vertex. So they have two arms and a vertex where the arms meet. The word vertex in math does actually just basically mean like corner. So when we use it in terms of parabolas, think that it's where the parabola stops going down and starts going up, or vice versa. And so it's kind of the same context here, where it's one line ends and another line begins. Those arms do have names, though, so we want to be able to differentiate between them. So the angles, when we draw them, typically have a direction to them. So if you look at this angle that we've got up here, usually there's going to be an arrow like this that shows you where you're starting from and where you're going to. So the initial arm, well, if you think of what the word initial means, not in terms of letters and names, but initial in terms of starting, the initial arm is the arm from which we are measuring. Basically, it's where you start. The other arm is pretty naturally where we finish, and it is called the terminal arm. So that's the line that we are measuring to. So you go from the initial arm to the terminal arm. Because terminal basically just means the end of something, right? It terminates. And so this arrow that we've got up here basically shows us which one's the initial arm and which one's the terminal arm. When we draw our angles on the Cartesian plane, which we're going to do a fair bit of in 2.1 and 2.2, there's a very specific way that you're supposed to draw them, so that if everybody was drawing a 40-degree angle, everybody would draw essentially the same thing. And so that method of drawing has a name, and it's called standard position. And so standard position has a couple of criteria that we're going to have to follow. So the first is that your initial arm, all right, so remember your starting line, is on the positive part of the x-axis. Okay, so it has to be the positive side, has to be the x-axis. The second criteria is that your vertex, your corner, has to be at the origin, which is just the point 0, 0, the point in the middle. And so if you follow those two criteria, in theory, everybody should be drawing their angles essentially the exact same way. So if we sketch this out in a little bit more detail, we don't need to worry about putting numbers on these things because we're not typically going to be measuring points in terms of length. We're just using it as sort of a frame. So my initial arm needs to be on the positive x-axis, but I can't start it, say, over here, because then my vertex is going to be in the wrong place. So we have to start right in the middle. So right there. And so my initial arm is going to be on the positive x-axis right here. My terminal arm will be wherever it needs to be to make my angle. So let's just put it somewhere up here for now. The exact spot doesn't really matter. I'm going to have that arrow that shows my direction. And sometimes we'll say what the angle is, whether it's a theta or whether it's an actual size, something like that in there. So this, again, is my terminal arm. This is my initial arm. And this is my vertex. All right, so I'm going to draw you a bunch of angles, and we're just going to talk about which ones are and are not in standard position for various reasons. So each of them is going to have its own characteristics. Some will be in standard position, some won't. So as I'm drawing them, take a look at them and see if you can figure out which ones are and which ones aren't meeting those two criterias that we've got above. All right, so we've got 8 angles here. If you want to do this yourself, feel free to pause me here, but if not, I'm just going to go through them now. So if we look at the first one in the top left, that one's not in standard position, and that's because our initial arm is on the negative x-axis, not the positive x-axis, so that one's a no. Our second one here is great, right? Initial arm's in the right spot, vertex is all good, so that one's a yes. Third one, initial arm's not on any part of the x-axis, so that's a no. It's in the right quadrant maybe, but it's in the wrong area. Fourth one's also a no, because even though it looks like the second one, you'll notice that the initial arm is this one down here. So that's not on the positive x-axis. The terminal arm is, but it's the wrong one. The next one, our vertex is in the wrong spot. So it's partially on the positive x-axis, but also partially on the negative x-axis because the vertex is in the wrong place. Same for the next one. For the next one down on the bottom, so second from the right, that one is actually fine. We'll talk about this in a sec, but there is a direction to angles. So even though this one is drawn sort of how we wouldn't expect to necessarily draw it, it's also fine. And then our last one here is just very wrong, right? Just looking at it, it should really stand out as just being completely and totally wrong. So that one's a no. So like I was just mentioning, when we're drawing angles in standard position, we typically do so counterclockwise. That's not a mandatory requirement. So this one up here that I'm going to circle in green, even though this one is going clockwise, it is still in standard position. But there is going to be something different about that one compared to the other ones. For anybody who doesn't know, counterclockwise means we go this way around the circle. And so because we typically go counterclockwise is considered a positive direction, and clockwise is considered negative. So there's nothing wrong with having a negative angle, but it is just something that you need to be aware of. So clockwise, negative, counterclockwise, positive. And so if we look at our angles in the context of the xy plane, right, our Cartesian plane, we start with the initial arm. So that's here. So that's going to be 0 degrees. We're going to go around from there. And so if you go around to here, this angle between these two lines is one that you should be pretty familiar with because that's just a right angle, which means this is considered to be 90 degrees, the positive y-axis. If you keep going, and you get halfway around, well, that's half of a circle, which makes it 180 degrees. If you go again down to the negative y-axis, that's 3/4 of the way around, and so you'll notice we're going up by 90 every time, so this is going to be 270. And then if you go all the way around, back to where you started, that would make this also 360 degrees. If you were going backwards, so you start at the initial arm, but you go the other direction, then this is also going to be negative 90 degrees down here. This would also be negative 180 if you go halfway around. This would be negative 270. And then if you get back to here, this would also be negative 360. We're not going to deal with the negative angles very often, so don't worry about them too much, but just know that that is a thing that can happen. And so our plane has 4 sections here. And these are divided up in a way that you probably would have learned in Math 10, maybe even Math 9. So we've got the 4 sections, which are called quadrants. Right? Quadrant comes from the word for 4. And they are numbered in a way that, so if everybody was talking about quadrant 3, everyone would be talking about the same place, for example. So we start sort of where our initial arm is. So that's quadrant 1 in the top right corner. And then we just go counterclockwise from there. So quadrant 2, quadrant 3, and quadrant 4. So quadrant 1 is everything from 0 degrees to 90 degrees, not including 0 and 90, so the angles on the axes don't count. So technically, if we were writing this properly, we would say it's everything between 0 and 90, but not including. We're not typically going to write those. Quadrant 2 is everything from 90 to 180. Quadrant 3 is 180 to 270. And 4 is 270 to 360. We can also go around more than one full circle. So if you went around, say, 400 degrees, that would be a full circle, and then a little bit further. Right? So that would put you back in quadrant 1. So it is entirely possible to have angles but like bigger than 360. But again, just like the negatives, it's not something we're going to deal with very often. Just know that it's a thing that exists. All right, so I'm going to throw some angles down here and see if you can figure out which quadrant they'd be in based off of just what the angle is. So you're going to have to get very familiar with the quadrants because knowing what goes where is going to be really important, whether it's you're drawing things or whether you're using them to do calculations or figuring out other things. You got to know what goes where. So if we started with, say, 105, so my thought process is basically, okay, that's between 90 and 180, which would put it in quadrant 2. So try doing these last 3 for yourself. So we've got 37 degrees, 193 degrees, and let's go negative 200 degrees. So try placing these 3, and then come back after you're done. All right, so angle 37 degrees, that is in quadrant 1. It's between 0 and 90. 193 is in quadrant 3, because it's between 180 and 270. And then negative 200. So if you started at 0, and you went back 180, that would put you here. And so you're going just a little bit further. So negative 200, that's going to be in quadrant 2. All right. So we do need to be able to draw these angles somewhat successfully. I will say now, I don't expect you, and I don't want you to be using a protractor to draw your angles when you're doing this in this course. It takes some time, and it's not really our goal. So we don't want exact drawings. What we are looking for is just a quick, rough sketch that puts it in approximately the right spot. So if you were asked, for example, to draw an 18-degree angle, your process should always start in the same place, and that's with your initial arm. So we sketch down an initial arm. Do make sure you draw it. So a lot of people get lazy, and they think, okay, well, the axis is already there, so I don't need it, but you do. So do make sure you have a very clearly shown initial arm on your angles. 18 degrees, that is in quadrant 1. And so it's up to us now to kind of figure out where to put it. So you gotta get a sense of sort of your halfway points and your halfways of your halfways. So if this is 90 degrees up at the top here, halfway between 0 and 90 is 45. So 18 degrees is still quite a bit smaller than 45. So if we were drawing this, I would probably put it somewhere down around here. I'm not going to measure it to make sure it's perfect, but that's roughly where I want it to be. So let's try another one. What if we wanted to do 300 degrees? So that, if we sketch out our grid, 300 degrees is going to be in quadrant 4. And so now we have to get a sense of ourselves of, okay, well, it's in quadrant 4, but where? So this is 270. This is 360. Halfway between 270 and 360 is 315. So we definitely need to make sure we're at least on the right side of half, and we don't want to be like right up against 270. So 300 is, it's closer to 270, but it's at least part way there. So I would put it somewhere around here. And so we have to draw that arrow to show our angle, and then put down 300 degrees. So every part of what I've got here, so the initial arm, the terminal arm, and this arrow showing my direction are all key parts of drawing an angle. You've got to have all of them. You don't have to have the actual written out angle, but it is helpful, especially when you're sketching it, just so that somebody who's looking at what you're drawing knows what it is they're looking at. All right, so I'm going to give you 2 of these to try on yourself. So you're going to do 135 degrees, and you're going to do 250 degrees. So try drawing those, and then come back once you're done. Okay, so 135. This one is a little bit special because this is one I would actually expect you to get pretty much perfectly. Because if you think about what you're doing, so 135 is going to be in quadrant 2, but a little more specifically than that, 135 is exactly halfway between 90 and 180. So that one you should be able to put exactly in the middle to get a perfect 135 degrees. 270 is not perfect and is not going to expect you to be right on the money. So it's going to be, well, it's closer to 270 than it is to 180. So I would put it probably somewhere, I don't know, around here. And so there you go, that's sketching angles. So the last thing we want to do in this section is just go the other way. So if I show you an angle, you also have to be able to estimate and tell me what you think it is. So again, no protractors, you're not measuring, you're just giving a quick estimation based off of what you're shown. So let's try 1 or 2 out with me helping you, and then you'll try a couple on your own. So looking at what we've got here, we'll have an initial arm, we'll have a terminal arm, we got our angle showing us, or our arrow showing us a direction. And so we need to come up with a fairly good approximation for this. So we're in quadrant 2, and it's definitely close to 180. So based off of what we got, I would probably put this personally at around 160 to 170. I'm going to go with 165. So if I was assessing you on your estimations, typically I'm going to expect you to be within roughly 10 degrees. And you have to kind of respect what you can tell for sure. So this isn't bigger than 180. So if you told me anything bigger than 180, that's definitely wrong. And it's not halfway there, right? So 135 was halfway, and this is definitely going to be a fair bit bigger than 135. So you got to kind of go along with those things to get the best approximation you can. So let's try another one. All right, so looking at this, again, we are in quadrant 3 now. And compared to the last one, this one's even closer to its axis. So it's not exactly 270, but it's right up against there. So for your last one, if you said that was 165, this one's going to have to be even closer. So if this was 165, we're basically saying that this was sort of a 15-degree difference. This is a smaller difference, so I would probably put this somewhere in the neighborhood of 275. Seems like a pretty good guess. 275 to 280. This is one where I probably wouldn't give you as much leeway just because it is so close that it can't be much bigger than that. All right, so last thing, I'm going to just give you 2 more of these. Take a look at them on your own, try to estimate them, and then once we're done that, we'll be done with this video. So your first one is going to look something like this. And your second one is going to look something like this. And I'll give you some directional arrows on there. They're both positive angles. So go ahead, estimate these, and then come back and see if your estimation is close to mine. All right, so for the one in the bottom left, right, we're between 180 and 270, definitely closer to 180. So a reasonable-ish approximation for this would probably be somewhere in the neighborhood of 210 degrees. And then for the next one, it's between 0 and 90. It's close to the middle, right? It's pretty, so 45 would be kind of, oops, even bigger than that. So 45, if I drew it properly, would look like this. So this is just a little bit bigger than 45. So I would probably put this at somewhere in the neighborhood of 50 degrees. And so there we have it. Those are angles in standard position. So make sure you get a handle on this. This is thankfully a pretty easy intro to the unit. Once you're ready, go ahead and move on to the next video, which will be about something called reference angles.